Hi, I'm Max Runnigan. I'm a junior in civil engineering, and for this semester for our course project in construction engineering, along with my two teammates Keith Crawford and Jacob Tooley, we will be talking about the BIM revolution. So we'll be giving you an overview over what BIM is, how it started, where it is today, how it works before and now, why it's needed, and why some people don't use it, and what's in store for the future for BIM. So what is Building Information Modeling, or BIM? BIM is the process of using software to take 2D imagery and build it into 3D imagery. So you can better visualize plans and scopes, so you can see projects in their entirety and find problems before they are there. So BIM started with the father of CAD, Patrick Hanarty, in 1957 when he developed Pronto. Ivan Sutherland then expanded upon this with the design of Sketchpad, which utilized an XY pointer display. Patrick Hanarty developed a new program called Atom, which ran with 16 and 32-bit computers. 80% of all CAD programs today get their roots in Atom. So the current day, what is being used? We have three major programs, those being AutoCAD, Revit, and CATIA. AutoCAD is the main one used, developed in 1982 with Sketchpad designs, and is one of the leading 2D and 3D modeling softwares with yearly updates. Revit is another member of the Autodesk family that focuses primarily in structure and system modeling. It's used mainly by firms as the primary architectural modeling software. And CATIA, made in 1981, is not used by many civil firms and is popular in mechanical engineering firms. Now I'm going to let Jacob Tooley talk to you more about the origins of BIM.
Hi, I'm Jacob Tooley and I'm currently a senior in civil engineering. So BIM works to translate ideas from the engineer's brain and get it onto construction documents so the construction workers can actually use what they have. So BIM gives a two-scale representation of a building's layout, mechanical systems, and everything else, architectural, plumbing, and anything needed. So BIM is not a part of the designing process, meaning you're not actually going to be doing this when you're generating your actual design, but rather you'll use this to fully convey your design to other people. And this is often used to create construction documents. So before there was building information modeling, it used to all be done by hand on these giant architecture tables. So these were all done on these tables that had a bunch of rulers and protractors and other like drawing utensils that they used to create everything by hand. Which, because everything was done by hand, that meant sometimes getting the actual documents to construction workers was a lot longer of a process than it is now, especially because they could potentially be damaged and harder to recover. But nowadays, we use building information modeling, and it's all done through the computers. So we use both 2D and 3D systems, which lead to a much more efficient process of communicating our designs. And what this actually does is this allows us to make the building as complete as possible so you can actually see everything the building entails. So why do we need this? Well, there's a couple reasons, but we're going to talk about three today. So the first is bid advantage. So when you're preparing a bid, sometimes it can be really frustrating to talk to a client and just hear them say, I'm not really seeing what you're designing. Well, if you use a 3D modeling software, you can actually drop them down into your structure and show them every little detail. In addition, this also helps correct for errors in the structure. Often when people are going through and designing things, sometimes the systems don't correlate very well, meaning you'll have mechanical systems running through your plumbing, which can obviously lead to a lot of problems. But with 3D software, you can actually eliminate those before you get to the field. And then finally, building information modeling allows for easy blueprint generation, which means it's a quicker process to get your idea to the construction workers to start construction. With that, I'll now pass it on to Keith Crawford, who will talk to you a little bit about why we're not currently using it and why we should be.
Hi, I'm Keith Crawford. I'm a sophomore in civil engineering here at Purdue. And so BIM is not being used due to a couple reasons. The CAD introduction 60 years ago took hold of the civil engineering field in 1971. And with these 2D modeling softwares being used for a very long period of time, these older generation firms aren't comfortable with moving to a 3D modeling system, and they see no problem with the current 2D modeling softwares. Along with this, these 3D modeling programs are still very expensive due to the lack of use in current civil engineering firms, and this can deter smaller companies from actually adopting the software in the first place. But as you can see, there's a steady rise of BIM usage and adoption in North America throughout the years. Now, in some cases, BIM is used, but it creates problems. Due to the lack of civil engineering firms adopting the BIM software, there are several firms that actually have no civil engineering background, but they take plans from a civil firm and generate a 3D model and construction blueprints. Now, this can cause a scenario called no last line in defense, meaning that if there's something not correct in the plans, it will be unnoticed in the construction documents generation. This can cause something like this bridge in Colombia that collapsed when there was a miscommunication and 2 numbers were replaced. A simple mistake, but had a disastrous effect.
At least 10 construction workers were killed and 8 injured when a partially constructed bridge near Bogota, Colombia, collapsed on Monday. The bridge, which was not yet open to public, was to be part of the highway that connects Bogota to the city of Villavicencio. 9 people died at the site and the 10th victim succumbed to injuries at the local hospital. In a statement, the Colombian Civil Defense said the victims were working on the project's drainage when the bridge collapsed.
Cuando de repente escuchamos un estruendo bastante fuerte, las guayas que van sosteniendo los teleféricos para hacer el montaje del puente empezaron a reventarse. Entonces, nosotros lo único que hicimos fue correr, tratar de evacuar. Había mucho humo, había desespero por todo lado. En el momento que evacuamos, volteamos a mirar hacia este lado, ya no estaba el pilón. Y nada, nos vinimos a tratar de ayudar a nuestros compañeros, pero desafortunadamente hay compañeros que fallecieron.
Transportation Minister Herman Cardona visited the site and said investigations had been launched to find the cause of the collapse.
Hombre, es una sensible tragedia, es una obra que tenía un porcentaje de avance inmensamente grande, próxima ya a culminarse, pero desafortunadamente hubo un colapso y esto todo forma parte de una investigación que ya le hemos solicitado al concesionario de esta obra, que se ponga al frente de esa investigación, lo mismo la interventoría, lo mismo la Agencia Nacional de Infraestructura lo va a hacer y lógicamente los entes de control. Lamentable la pérdida de 9 vidas humanas, 8 personas heridas y gracias a Dios la mayoría de la gente estaba del otro lado del puente y por eso la tragedia no fue de enormes proporciones.
In an official tweet, President Juan Manuel Santos said, "All my solidarity with relatives of the victims. A search and rescue mission is underway."
So, with the use of BIM in the future, and as it slowly gets adopted by more and more firms, this can minimize errors in construction, which can lead to saving money and saving time. Along with this, bids will no longer be turned down due to an unclear vision. Designers can now, with the 3D capabilities of BIM softwares, they can fully visualize their ideas and communicate them. BIM also gives a last line of defense in civil engineering firms. This can minimize errors in the construction and minimize cases like the bridge in Colombia. Thank you for watching.